All right, so we're going to come back here and I'm going to show you what the unit circle is going to look like when we fill in our 30s, 60s degrees. I did the 45s in a separate triangle, but I'll show you a separate video, but I'll show you what the completed unit circle looks like at the end of this. So when we look at this, I'm dealing with my 30, 60, 90 degree triangles right now. So dealing with my 30, 60, 90 degree triangles, I drew a 30, 60, 90 triangle here. I actually measured it using the protractor. This is 30 degrees, so I'm just going to go ahead and put my dot here at 30. Okay, so I know that. Now, I'm also showing you here this relationship for the 30, 60, 90 right triangles. If you need to review that relationship, you might want to go back and look. I posted some videos from Khan Academy about how that 30, 60, 90 triangle works, so you might want to look at that. In the unit circle, our hypotenuse is the radius, and since it's a unit circle, our hypotenuse is 1. So since that's telling me that my radius is 1, that's also telling me that this coordinate down here is the square root of 3 divided by 2, and this is 1/2. So this is the square root of 3 divided by 2, and this is 1/2, which allows me to now figure out what my sine and cosine are. So my sine is the y value, my cosine is the x value. So my x value is the square root of 3 divided by 2, and my y value is 1/2. Okay, so that's my coordinate for 30 degrees. Okay, so I've got my coordinate for 30 degrees there. Now, what would that be in radians? Well, if I'm trying to figure out what that would be in radians, well, I need to convert 30 degrees to radians. So 30 degrees, am I going to multiply by pi over 180 or 180 over pi? Well, I'm going to multiply by pi over 180 because I want the degrees to cancel. So we cancel the degrees. So we now have 30 divided by 180. So I know that that could be 3 pi over 18. And I know that 18 divides by 3 6 times, so that tells me that this is pi over 6. So 30 degrees is the same as pi over 6 radians. Now, the other thing we need to figure out for this particular unit circle is our tangent, but we'll come back to that in a second. So right now I have this 30-degree angle, and I want to put that in not just the first quadrant. That angle is going to appear in the second, in the third, and in the fourth quadrant as well. So I want to make sure that I have that in all 3 of my quadrants. Well, if I reflect my triangle over the x-axis, so if I take this triangle and I reflect it over the x-axis, now since I went that way, this is 30 degrees short of being 360 degrees. So 30 degrees short of 360 degrees is 330 degrees. Okay, so I know that. Now, if I'm looking for my ordered pairs, well, when I reflected over the x-axis, my x-coordinates stayed the same. So I still have the square root of 3 over 2. For x, that's my cosine, but my sine is going to be the opposites because it's in the fourth quadrant. All right, beautiful. So what do I multiply by 30 to get 330? 11. So 11 times pi over 6, that's my degree. That's my radians. So now I have my angle in the first quadrant and I have it in the fourth quadrant. Well, what if I took my angle and instead of reflecting my triangle over the x-axis, I reflected it over the y-axis? So this time I'm dealing with the supplement. So I'm stopping 30 degrees short of 180. So since I'm stopping 30 degrees short, so that's 180 minus 30, which is going to be 150 degrees. 150 divided by 30 is 5. So that's going to be 5 pi divided by 6. So now what's my coordinate? Well, if I reflect over the y-axis, it's the x that changes. So instead of this being positive square root of 3 over 2, over here it's negative square root 3 divided by 2. And the y value will stay the same, so it will be positive 1/2. Okay? And then lastly, when we bring this down here, we're not doing 30 degrees beyond, we're doing a half turn. So we're just adding 30 degrees to 180. So when we add 30 degrees to 180, that's 210. So I'm going to go ahead and put my dot there. I know that's 210 degrees. 210 divided by 30 is 7. So that's 7 pi over 6. And what would my coordinate be? Well, in the third quadrant, both are negative. So I have negative square root of 3 divided by 2. And I have negative 1/2. Now you should notice that we put in all of our sines, we put in all of our cosines, and we put in all of our degrees, we put in all of our radians, but what we didn't put in was our tangents. So we have to calculate what our tangents would be. So if I'm looking at my tangents here, well, tangent is, as you can see at the top, the sine divided by the cosine. So I want to figure out what that sine divided by the cosine is. So if I look at this, I'm going to start with my 30 degrees, because that's the triangle with the angle we started everything with. So I got my workspace. The tangent of 30 is the sine of 30 divided by the cosine of 30. Okay? Sine of 30 is 1/2 divided by the cosine of 30, which is the square root of 3 divided by 2. So because we're dividing fractions, we're multiplying by the reciprocal, so we have 1/2 times 2 divided by the square root of 3. Our 2's cancel out. That gives us 1 divided by the square root of 3. Can't leave our denominator having a radical in it, so we multiply numerator and denominator by the square root of 3. So we now have the square root of 3 divided by 3. And that's the tangent of 30 degrees. So that tells me my tangent here is the square root of 3 divided by 3. So in the first quadrant, the tangent's positive because it's positive divided by a negative, by a positive. Positive divided by positive is positive. In the second quadrant, I have the same numbers but different signs. So a positive divided by a negative would be a negative. So that means that this would be negative square root of 3 divided by 3. In the third quadrant, I have a negative divided by a negative, which means this would be positive. So I would have the square root of 3 divided by 3. In the fourth quadrant, I have a negative divided by a positive, which would be a negative. So I have negative square root of 3 divided by 3. Excuse me. Beautiful, right? Okay, so that's our 30-degree triangle, 30-degree angle. What's the complement of 30 degrees? Right, 60 degrees. So we have our complements angle, our complements theorem, which says if we reflect over the line y equals x, so by folding my triangle here, I've given myself the line y equals x. If I reflect this triangle, which my 30 degrees is, right, here, so that this part's the 30, that means that this part here would be 60 degrees. True? And that means that my ordered pair would switch, because when we do reflect over the line y equals x, it switches our x's and our y's. Okay, so the sine of 60 is 1/2. The cosine of 60 is 1/2. The sine of 60 is the square root of 3 over 2. Now, 60 degrees is how many radians? I'm glad you asked. Well, 60 degrees is 2 times 30 degrees. 30 degrees is pi over 6. So that's 2 pi over 6, which could be pi over 3. So that tells me that 60 degrees is really the same as pi over 3. All right, let's put it in the 4 different quadrants. Let's put it in the 3 other quadrants. So if I reflect my triangle so that instead of being here for 60 degrees, I reflect it over the x-axis, it's now down here. So here's my triangle. What's this angle? So this is negative 60. Well, 360 minus 60 would be 300. So this is 300 degrees. Okay, so if I'm thinking about that, all right, well, 300 degrees, 60 goes into 300 degrees 5 times. So that's 5 pi over 3. Now, what's my ordered pair? Well, my ordered pair up here is positive 1/2 and positive square root of 3 over 2. When I reflect to the 4th quadrant, the x stays the same, and the y is the opposite. And there's that ordered pair. So now what if I reflect instead, take this 60, which I had marked like this, and I move it to the 2nd quadrant. All right, so that means I'm 30 past 90, which is 110. Oh, excuse me, 120. 120 is 2 times 60, which is 2 pi over 3. And then when I reflect over the y-axis, the x is what changes. So it was positive. Over here, it's going to be negative 1/2. And my y stays the same. It was positive square root of 3 over 2, so that's what it's going to be here. And then if I take that same triangle and I flip it now here, so I'm 60 degrees past 180, that tells me that my angle is 240 degrees. 60 goes into 240 4 times, so that lets this be 4 pi over 3. And then my ordered pair, in the 3rd quadrant, they're both negative. So I have negative 1/2, and I have negative square root of 3 divided by 2. So the only thing left to fill in here is the tangent. So we know the tangent is sine divided by cosine. So the tangent of 60 is the sine of 60 divided by the cosine of 60. So that's the square root of 3 divided by 2 divided by 1/2. So we have the square root of 3 over 2 times 2 over 1. The 2's cancel, so we just have the square root of 3. So that's our tangent of 60. Which means that the tangent here is the square root of 3. So using the same logic we did on the last angle, we can do the same thing here. In the 2nd quadrant, tangent's going to be negative. In the 3rd quadrant, tangent's going to be positive. In the 4th quadrant, tangent's going to be negative. And that takes care of our 30 and our 60 degree multiples. Okay, and then when you put them together, that's what it looks like with your sine and your cosine and everything.